Hello, Professor. My name is Chintan Kevaria. Master ID is 101236361. Today we are going to go over assignment 1. Okay, so this is our task. We have to load the dataset MNIST like version. There are suppose 10,000 images and the dataset contains 10% categories like such as t-shirt, trouser, pullover, dress, coat, sandals, shirts, sneakers, bag, and ankle boot. We are going to perform some task on that, and over here there are 20 tasks to do. Let's just go over it. First of all, we just ask you to import the data set MNIST, face MNIST. So we are just training image, train labels like test dates and test labels. We're just loading our data set from here. First, I ask you to what are the dimensions of train images, train labels, test images, and test labels. So I'm just printing our the dimension of the train image. It's 3. The next one is the test label dimension is 1. Second question is what are the length of the train labels and test labels. So over here, as I said earlier, it's 60,000 images of the data set. So just printing the len using the object len. Yeah. The next one is saying please show some of the train and test labels. So over here, just printing index of zeros, and in the test labels, just printing 0, 1, 2 respectively. The next one is says please show the digital content of the image index file. So from our database is asking us to show what does the index file image contain. So I know it's hard to read, it's not even readable, but it's from like basically from number 0 to 255. The maximum 0 means the not lighten, and the 251 is lighten 2 is best. The next one is asking us to show the image from index file datasets. So we are using Pipelette library PLT from we just have to import that library and show the image. So I'm just getting over here the index file. So it looks like a pullover, but let's just see what's this area and come to. What's the label for the index file and the 10 looking up to in the whole list? What does it mean? So as I said earlier, computer's gonna decide based on and it's gonna predict to its best after some meta and error. So it's label 25 seconds. So that means second is for pullover. So yeah, I got it right. Next one is saying do the same thing for index 500. So again, some zeros and ones and lots of different numbers. The same thing here looks like it's a very blurry. So I think it's hard to guess for the computer to decide to come to a conclusion. Next one is say what is the label for the index 500. This one I'm looking at in the pull list. What does it mean? So this again come to the conclusion. Pullover number index 2. Number 10 says please import model and layers from the Keras library. So we're just doing I'm importing the models from Keras, and from TensorFlow I'm importing layers. Define a sequential model and call it my network. So just create one sequential model and call it my network. Okay, this is instruction. So in here, reshaping the image from 28 to 22 column with 784 newtons. I'm planning use 2 methods, one from Google and one from that video. Alright. So we are just basically reshaping those images from into 20 into 10 digits. 60,000 images there and 10,000. That's a train image and that's test images. Using the flattening method, I'll show you. Okay, I'll show you there at the end. Yeah, it's the flattening method. So train image, just that's it. Okay, so that's shaping the images into different size. Okay, so from the TensorFlow, we inputting the utils, normalizing our data set. Train image access as 1, doing the same thing for the testing the image and the train image access 1. Over here, we are dividing every image by 255 floatings. So I'll give you the art from 0 to worry based on that. It's not readable in the format. The next one is to add one hidden layer that has a 512 neurons using Rayleigh activation. So whatever declared the my network, be adding a layer against 512 neurons and activation is ReLU as it says here. We are adding one more layer, but not with the same neurons. It's 128 neurons, and activation is the ReLU against the same one. Okay, over here asking us to add the last layer as a 10 neurons dense layer. This uses the softmax, the activation key. So what is software and why do we use software? So softmax function is used for the activation function in output layer of the neural networks, and that predicts the multinational probability distribution. There is software is used as activation function for multi-class classification problem. The class member should require on one or more than two class labels. So we just changing this neuron to 10 and activation is softmax. Use the following setting for, and so we have just running those accuracy tests. Optimizes Atom and we optimizes Storm. So in this example, we are epoching. The epoch is 10, right? So it's gonna go over 10 times. So it's really bad actually. Look at the first figure, it's 1.4 loss functions. Like loss score is way higher than expected, but gradually it's doing better. The accuracy was 0.43 in the first half, whereas in the second you see 20% increase and reach 63.99. So after the last one, the loss score decreased to 0.5299, which is not that good, but not even that bad. So and we got the highest accuracy above the all round, of course, and that's 0.89%, which is not that bad. It's okay for this round. Otherwise, whatever we did in the class for the MNIST test set, that was way higher than this one. It was around 98 or 99. But I think just because of the overfitting, we're not getting that exercise right. How do you compare the first what we learned next? What we can in the difference and the accuracy? What could be the reason for that? I think what we learned in class in how machine categorized and reached to the conclusion. In class, accuracy was higher, and I think it was easier for computer to predict the numbers compared to the picture from the database. That's what I think actually. Use the ability to calculate achieve the accuracy loss over the 10 test images and the labels. Do we have overfitting? Yes, I think we had some overfitting. Well, because we're fitting the scale on the data we fetch of the 10, and accuracy we got at the end was 0.7878, and the loss function was a bit higher, like getting a loss score of 0.5754. So that's I think learn more. We should get probably around like 10 or 0.510. 0.5 or 10, so something like that. We're explaining better. I think that's it. Thank you so much for watching.